In this video, we move on to chapter 5, and section 5.1 is all about sequences. So what is a sequence, right? In the most simplest way we can describe a sequence is a list of numbers that goes on forever and ever. And later on we'll talk about series, but I just want to distinguish the two right off of the bat. So hopefully this sticks. And the difference between a sequence and a series is that a series is a sum of an infinite amount of numbers. Alright, so let's formally introduce a sequence. So for the definition, an infinite sequence an, and this is the notation that we use, is curly braces a with a subscript n. For a sequence is an ordered list of numbers. A1, right? So that curly brace an expands to a list A1, A2, A3, A4, so on and so forth, right? You reach an plus 1, so on and so forth. It goes on forever. So each of the numbers in the sequence is called a term. So let's highlight our vocabulary words here. So a term, so for example, A1 is what we call the first term. A2 is what we call the second term, right? And then an is what we call the nth term. And so the n, the subscript n, is actually what we call the index. So that tells you, right, that tells you what term you're on. So the 1 corresponds for the first term, the 2 for the second term, right? And if we look at the whole list, the 3 for the third term, 4 for the fourth term, n for the nth term, n for the n plus 1 term, and so on and so forth. So the subscript n is called the index variable, or simply just the index, which tells you what term of the sequence you're on. So naturally, n is a positive integer. And what does that mean? Right, a positive integer, remember that integer is just a whole number. So it's a positive whole number, right? Because it doesn't make sense for us to say we're on the negative first term or we're on the 1.5 term when we're talking about a list, right? You're either the first, the second, the third, the fourth, the fifth, the sixth, so on and so forth. And the notation that we use for integers is this boldface Z. And if we want to indicate, right, so that's all of the whole numbers. If we want to indicate that it's positive, we put a little plus superscript there. And the notation that we use is that n is in Z. And so this little symbol here is a little symbol that means is in math. All right. So let's look at an actual example of a sequence. So let's say we were given the sequence 2, 4, 8, 16, 32, and so on and so forth. And I'm actually going to bring this on to the next page just to give me some more space. Right, so like I said, right, the first term, A1, is 2 in this case. The second term, A2, is 4. Right, the third term, A3, is 8. Right, the fourth term, A4, is 16. Right, and then the fifth term, A5, is 32. And what we want to figure out is how can we write a formula for AN? So we have to look at all of our previous terms. So if we look at 2, we know that we go from 2 to 4 by multiplying by 2, right? And then we know to go to 4 to 8, we multiply by 2. To go from 8 to 16, we multiply by 2. So that's our pattern, that we're multiplying by 2 every time. So we can rewrite our terms in this sequence, right, as multiples of 2, right? So I know that 2 is just 2 to the first power. And then I know that 2 to the first power times 2, right, that's 2 squared. And then I know that 8 is 2 cubed, and 16 is 2 to the 4th, and 32 is 2 to the 5th, right? So then if I take a close look, the index of each term corresponds to the exponent on the 2 each term. So then when I'm trying to figure out a formula to n, I know that the subscript corresponds to the exponent on 2. So we can write the nth term, an, as 2 to the n. Therefore, we can denote this sequence. Remember, what we use for the notation of a sequence is the curly braces. So our sequence here is to the n, or, right, this also means that we take n and we start it at 1 and we count all the integers up into infinity, because remember, this list goes on forever and ever. So basically what we do, and our goal a lot of the times, is to write a function to express the terms of our sequence. And when we do this, what we're doing is writing our sequence as an explicit formula. So this is how we write sequences by an explicit formula, right, where an is equal to some function of n. For some function f of n, where n is defined over the positive integers. And so that's one way we can write a sequence. The other way is by what we call a recurrence relation. So otherwise we can define a sequence using a recurrence relation. And that will be another vocabulary word. And with a recurrence relation, basically what we do is that, so in a recurrence relation, one term or more, normally it's one, but it can be more than one, of the sequence is given explicitly, and the rest of the terms are defined in terms of that term, or those few terms, if we do more than one. All right, so how about we do this for the example that we just did so that we can see what the difference is. So again, the sequence we're given is 2, 4, 6, 8, 16, and 32, and so on and so forth. And we said that we know that A1 is 2, A2 is 4, A3 is 8, A4. Oh, this 6 should not be here. I'm just making stuff up. I started counting by the even numbers. So 2, 4, 8, 16, 32. Yep. 2, 4, 8, 16. Right, and we said to get from one term to the other, we noticed that we multiplied by 2. So if we want to write our sequence in terms of one term, write all the other terms in terms of one term, right, we're going to have to start with 2 and say we just multiply by 2 every time to get the next one. So as a recurrence relation, we say that AN is equals to A1, which is 2, and then AN is equals to 2 times the term before that, right? So if we're saying that we're trying to define a formula for the nth term, well, we got to take the term before the nth term, which is just n minus 1, and multiply that by 2, and that'll give us the next term, right? So for example, if I'm saying n is 2, right, then A2 is equals to 2 times A2 minus 1. So A2 is equals to 2 times A1, which is true, right? Because I take 2 and I multiply A1 I had was 2, and that gives me 4. Right? So how about so this was when we let n equal 2, and then if we let n equal 3, right, then A3 is equals to 2 times A3 minus 1, right? Which obviously we know 3 minus 1 is just 2. And so then we take 2 and we multiply it by A2 we know is 4. And that gives us 8, which is A3. So this is what we mean by a recurrence relation. So note, there are 2 types of sequences that happen very often, so they have special names. So 2 types of sequences that occur often, and so they're given special names, which are 1, arithmetic sequences, and geometric sequences. So let's start by defining an arithmetic sequence. So in an arithmetic sequence, the difference between every pair of consecutive terms is the same. So what does that mean? In other words, right, we're saying that the difference between two consecutive terms is always the same. That means that we add, so in a more colloquial way, we add the same number, right, or constant, whatever you want to call it, to each term to get the next term. So they have the form, right? Generally, they have the form an is equals to some constant plus some constant b. So, for example, the sequence 3, 7, 11, 15, 19, so on and so forth, right? So the difference we see between each pair of consecutive terms, and consecutive, remember, that just means like the one immediately before or the one immediately after, is 4. So this is an arithmetic sequence. So we know this starts at 3 and we add 4 each time. So it's easy to write this as a recurrence relation, right? Okay, so as a recurrence relation, we would say A1 is 3, and then AN, right, you just take the term before, right, if we're on the nth term, we take the term before that, and we just add 4 to it every time. And this is true for every term except the first one. Right, so if we let n be 2, right, then A2 is equals to A2 minus 1 plus 4. Right, so A2 minus 1, that's just A1 plus 4. And A1 we said is 3 plus 4, which gives us 7, which we see is the second term. And then how about we talk a little bit about geometric sequences. So in a geometric sequence, the ratio, right, instead of the difference, is the ratio between every pair of consecutive terms is the same. Right, so what do we mean by that, right? That means that we multiply by the same constant or number, whatever you want to call it, each term to get the next term. So we actually already saw an example of a geometric sequence, right? When we're dealing with this multiplying by 2 each time, right? This is a geometric sequence. We just didn't know the name yet. All right. And so in general, geometric sequences have the form an equals to c times r to the n, right? Where c is the constant and r is the ratio. So when we look at the example that we had, where we had an is 2, 4, 8, 16, 32, so on and so forth, right, we saw that we could write an as 2 to the n, right? So this is our r here, and actually we could see this as an equals 1 times 2 to the n, right? So this is the constant, and this is the ratio, r. All right, I'll stop there for this video, and we'll continue this section in the next one.